Hello boys and girls, Mr. Giomini. Wanted to come to you with some examples from lesson 4.5, dividing decimals and integers by decimals. Yesterday was dividing decimals by integers, where we just had the decimals in the dividend. Today we're going to have decimals both in the dividend and in the divisor. So we have them in two places as opposed to one. Now I'm going to focus on, for this video, I'm going to focus on 15, 17, and 19. I'm just going to focus on the odd problems here. I will actually post the answers to 14, 16, and 18 once I'm done with these three problems. First thing I'm going to do is I'm going to actually write this problem out. I'm just going to transfer what they have written there. Negative 408 thousandths divided by 3 4/10. Now, what I notice first of all is this is going to go in, so that is my dividend. This is going to stay out. That is my divisor. Now, as I said, yesterday we were okay with having decimals in the dividend. Now we have decimals in the divisor. I need to get rid of that decimal in the divisor. It becomes extremely difficult to multiply when there's a decimal in the divisor, so we're going to get rid of it. And we're going to get rid of it by multiplying, because the inverse of division here is multiply, but it's not so much the inverse here of this as we need to move this decimal one place over to make this a whole number and not a decimal number. Now, what we want to do is we want to multiply, we want to move the decimal one place to the right. So we want to make this bigger by 1 power of 10. So 10 to the first power would be 10. We're going to multiply both numbers by 10, both the divisor and the dividend. Kind of like when we're making equivalent fractions, where we do the denominator, we do to the numerator. We're going to multiply the numerator by, we multiply the denominator by. Same thing here. We want to keep a nice balance here. So whatever I do to the divisor, I must do to the dividend. So by multiplying this by 10, it really moves the decimal one place to the right. And by multiplying this by 10, it moves the decimal one place to the right. Now my new division problem becomes 4 8/100 divided by 34. Now I don't really need that 0 there, so when I write the division problem out as we typically see it, I'm going to get rid of that 0. But it still stays a negative, so now it's negative 4 8/100 divided by 34. A couple things I'm going to do before I begin to divide. I'm going to transfer that decimal up into my quotient, and I see I have a negative divided by a positive. That's going to give me a negative answer. Now I'm going to start just asking myself some questions. Does 34 go into 4? Is anything times 34, any whole number times 34, give me 4? And the answer would be no, so I'll put a 0 there. Now 34 can go into 40, so it didn't go into 4, but now we're looking at it as 40 because we don't bring the decimal down. We now look at this as 40. We just bring the decimal up. 34 goes into 40 one time. That gives me 34. I will now subtract. That is 6. I bring down the next digit, or next number, which is 8. What times 34 gives me 8? The answer would be 2, because 2 times 4 is 8. 2 times 3 is 6. Now if I can't see that how I'm doing this, you can always write over here 34 times 2. That's essentially what you're doing. Or that is what you're doing. 4 times 2 is 8. 3 times 2 is 6. That gives me 68. I have nothing left, so that's a 0. My answer to this one would be negative 12/100. Okay, negative 12/100. Let's take a look at number 17. I am just going to transfer the way they have it written down up there, down here. Similar process, a little different now because we have 2 decimal places, or 2 digits to the right of the decimal place in the divisor. So I have negative 1 12/100 divided by 8/100. Now the first thing I notice is I got to identify which number here is the divisor, and that would be the second number. I notice I have to move it over once, twice, and each one of these moves are powers of 10. So times that by 10 to the second power, or times that by 100. So I'll times this by 100. Times this by 100. If I times negative 1 12/100 by 100, it moves the decimal over once, twice. So this now becomes negative 112. And I will divide that by, again, I multiply this by 100, moves the decimal 2 places to the right. 1 power of 10, 2 powers of 10. That would give me 8. If I want to write this now as I typically attack or approach a division problem, I'll put the negative 112 as my dividend divided by 8. Okay, first couple of things here I notice. I would have a decimal point right here. I will transfer it up into my quotient. I will add 2 zeros. May not need them. I'll just put them there in case. Let me extend that division bar. I see I have a negative divided by a positive. That's going to give me a negative. And let's just start to do some division. 8 does not go into 1, but 8 will go into 11 one time. 1 times 8 is 8. I now subtract. 11 minus 8, notice how my place values lined up. 11 minus 8 is 3. I bring down the next number, which is 2. I ask myself, does 8 go into 32? What times 8 gives me 32? The correct answer would be 4. 8 times 4 is 32. I am done because there's no remainder and there's nothing else to bring down. Besides more zeros, and that won't do anything. I can rewrite this number because it looks a little odd with the 0 in front, so that becomes negative 14. So negative 1 and 1/12 divided by 8 hundredths, excuse me, not negative 1 and 1/12, negative 1 and 12 hundredths divided by 8 hundredths gives me negative 14. And let's look at one last one here. Let's look at the last one there. It is 14 and 7/10 divided by 3 and 5/10. First thing I notice, even if I say this, I have tenths, 5/10 in the divisor, I want to get rid of the tenths. So to get rid of the tenths would be to multiply by 10. Multiply by 10. So I multiply everything in this division problem by 10, which simply just moves the decimal place one place to the right, making it 10 times larger. Now this problem is written as 147 divided by 35. Recall, this goes in, this goes out. If I were to write this now, I have 147 divided by 35. I am going to add a decimal at the end of 147. Don't know if I'll need to use it as far as maybe it just ends in the ones place, but just in case, and I'll add 2 zeros. I will now transfer that decimal up into my quotient, and I'll begin to ask myself these questions. Does 35 go into 1? No. Does 35 go into now 14? No. Does 35 go into 147? Well, yes, it does. Now, I could do a couple things. I could go over here to the left because let's say I'm not really sure. I'm not good with multiplying. My multiples of 35. I know 35 times 2 gives me 70, but let's try 35 times, if 35 times 2 gives me 70, 30 times 4 would just double that. Wouldn't that give me 140? Let's see, 5 times 4 is 20. 4 times 3 is 12, plus 2 is 140. Hey, that's really close to 147. If I add another group of 35, that's way over. So I know I put a 4 here, excuse me. 4 times 35, we did the math over here, gives me 140. I will now subtract. 7 minus 0 is 0. The 4 minus 4 is 0. 1 minus 1 is 0. I think I said 7 minus 0 is 0, but I would say 7 minus 0 is 7. Now, I have 7, but I bring down another digit, which in this case is a 0. Now, I already stated earlier that I know 35 doubled is 70, so to double it means to times it by 2. 35 times 2 gives me 70. I subtract, and I have nothing left over. There would be my answer. Now, this is a positive divided by a positive, so my answer is a positive. So that would be 4 and 2/10. Now, I did promise you that I would tell you the answers to the other questions. Number 14. If you do number 14 on your own, and you want to see if you get it right, correct answer for that would be, 2,709. Large number. For question 16, if you do it on your own, correct answer would be -7. And then for question number 18, if you do it, you should get 10 and 7/10. Okay, let's take a look now at application of this skill and how we'd use it day to day. Now, it's kind of nice because gas prices have been dropping, but when they weren't, you really wanted to worry about your fuel economy, how many miles you get per gallon. And you could increase your miles per gallon by different things, having your tires inflated correctly, maybe not driving aggressively when the light turns green. Instead of gassing it hitting the gas pedal real quick, you gingerly go into the acceleration of the car. But now the gas is now under $3 a gallon. It's great, but we can still do things to conserve fuel mileage or to conserve gas. But let's take a look now at Lonnie. Now, Lonnie is driving a truck. So Lonnie used 26 and 3/4 or 27 or 26 and 7/500 gallons of gas to drive his truck 508 and 2/500 or 508 1/4 miles. What was his truck's gas mileage? Meaning, how many miles did he get per gallon? I want to take miles. I want to figure out miles per gallon. How many miles did he travel on 1 gallon of gas? What that tells me to do now is take that miles, which is 508 and 2/500, and divide that by gallons of gas that he had, or that he started with, which is 26 and 7/500. Now I could write it like this. I could also write it like this: 508 and 2/500 divided by how many miles I traveled total by how many gallons I started with, which is 26 and 1/4 or 3/4 or 26 and 7/500. I'm going to actually erase the first thing I did there, and let's start like we did the last couple problems and say, okay, where's my divisor? This is my divisor. I notice that they have 2 numbers to the right of the decimal. I need to get rid of those. So because it's 2, we're going by base 10 here, we're going to multiply by 10 to the 2nd power, or by 100. So I'll multiply this by 100. If I multiply this by 100, it moves the decimal, it gets 100 bigger, so that becomes 50,825. Oh my goodness, it'll be a big number to divide. Divided by, again, move that decimal 2 places to the right, divided by 2,675. Now, some of us might be frightened by these big numbers. Nothing to be worried about. We can divide, we can multiply. We should be able to handle this problem. Taking a look at this, and there's a decimal here in the dividend, so I'll put it there. I'll transfer it up in my quotient. Okay, I know that 2,675 does not go into 5. It does not go into 50. Let's try 508. No, because 2,675 is bigger. But let's try 5,082. Well, it definitely goes into that. But how many times? Well, I know once would just be 2,675. But let's try doubling it. So let's go 2,675 and times it by 2. So 2,675, and we'll double it. We'll times it by 2. Let's just see if that gives me under, because I need it to be under 5,082, but I want it to be close to it. That's 10, 14, 15, 12, 13, 4, and 5. Well, that's too large, meaning it can only go then in once. I can't do 1 1/2. I mean, you can only put one whole number here at a time. You can't do decimals up top as far as putting in how many times it goes into something. We go one time. Oh, that's easy, so that'd just be 2,675. I will now subtract. Sorry about that line there. Let's see if I can straighten that out. So I'm going 5,082 minus 2,675. That looks a little better. That's 12, so that gives me a 7. This becomes a 7. That's 0. I cannot take 6 from 0. I need to borrow from the thousands place here, so that becomes 4,000. That would become 100. This really becomes, or it becomes 1,000, excuse me. That'd be 1,000 minus, because we have 10 hundreds, so it's 1,000 minus essentially 600, which is 400. And then we have essentially 4,000 minus 2,000. That would give me 2,000 left over. I will bring the next number down, which in this case is a 5. Now I have 24,075. Now I'm pretty decent with my numbers, and I know that if I multiply 2,675 by 10, I'd get 26,750. That'd be too big, and I can't put a 2-digit number up here. I can only put 1. Now 26,750 is close to 24,075, but again, I can't put a 10 up here. So let's take one less group of 2,675. Let's take now 9 groups and see what that does. 9, and again, you can write this over here if it's hard for you to multiply as I was doing earlier. I could just take it and overwrite it over here, times by 9. We have 9 times 5 is 45. We have 9 times 7 is 63, plus 4 is 67. We have 9 times 6 is 54, plus 6 gives me 60. We have 9 times 2 is 18, plus 6 gives me, oh, I love it. It gives me exactly 24,075. I have nothing left over. I do not need to bring anything down because there's no other numbers besides 0 to bring down, so there is my answer. this car is going to get 19, or excuse me, this truck is getting 19 miles per gallon, which is not bad for a truck to get 19 miles per gallon. Now, the last problem, and I'm not going to solve this one for you, we'll talk about it, says Mitchell walked 8.5 or 8 5/10 laps in 20 4/10 minutes. Now, it says if he walked each lap at the same pace, how long did it take him to walk one full lap? Okay, so he walked 8.5 laps, and he did that in 20 4/10 minutes. If he walked each lap at the same pace, how long did it take him to walk one full lap? Now let's see, what am I doing here? I want to see how long, so I'm trying to figure out time. It would make sense that I would take the time, which is 20 4/10 minutes, and divide it by how many laps I did, which was 8 5/10 laps, or 8.5 laps, and see how long that would give me to just do one full lap. There is your setup. Think about what you would do, multiply both sides of this division problem by to get rid of that 5/10 in the, I want to get rid of that decimal, so get rid of the 5/10 in the divisor. Think about what I'd multiply it. I'd make one move over, so think of power of 10, 10 to the first power, and go from there. If you do this problem correctly, you should get, it's going to take you roughly 2 4/10 minutes. I'll write the word minutes out. Per lap. All right, good luck with that. Take care. Bye.